Alright everybody, so far we have learned that there is an inverse relationship between acceleration and mass. As in, when the mass of an object gets bigger, the acceleration on it gets smaller. So now let's investigate what the relationship is between acceleration and force. And to do that, I've got actually kind of a real easy but cheesy experiment that we can do. So I've got the same smart cart from before. This time, instead of a fan pushing it, I'm going to be the one pushing it, and I'm going to push and pull it from this hook on the back of it, which is connected to the force sensor that's built into the smart cart. So the smart cart, in addition to measuring positions, velocities, and accelerations, will also measure force. And so on the capstone program, I've got a graph of acceleration on the y-axis and force on the left axis. Excuse me, the x-axis. And so when I press record, nothing happens at first because I'm not doing anything. So let's push and pull on this. I'm just pushing and pulling it at random. And what you'll see on the graph is this really nice straight line. So let's give it a really big push. So you saw that point up there, big pull. You saw that point down there. And so when you graph acceleration versus force, you get this nice line, a little wiggles and things, you know, aside. So now we can see that the acceleration of an object is directly proportional to the force exerted on it. So we get that nice straight line on our graph of A versus F. These two facts together comprise what is commonly known as Newton's second law. And if we want to smush those two mathematical relationships together, we can do that. And when we do that, it kind of looks like this. Acceleration is equal to force over mass. Now the caveat behind the equal sign is that we have to have our unit for force be such that it is equal to a kilogram times a meter per second squared. And so that's where we get our definition of a Newton from. We had chose it to make that equal sign actually be an equal sign. Now a lot of times you'll see the equation part of Newton's second law written as F equals ma. That's just to make it easier for kids who are really bad at algebra to solve basic physics problems. But we need to not write it like that. We need to write it like this. Acceleration is equal to force over mass, so that we understand that it's the force and the mass together that can change the acceleration. That's the gist behind one of the most important rules we're going to learn this year in physics. So, till next time, ta-ta.